Hello students, welcome back to Akshar IT Foundation classes. I am your chemistry faculty S. Mohan. So students, 8th class. 8th class, the volume 2, we started the chapter called solutions. In that we are completed 1 and 2 synopsis. Today we are going to discuss about the synopsis 3. So topic is solutions. Solutions in that synopsis 3. Right. So in the synopsis 2, we discuss about the concentration of the solution. Right. So concentration means what? The amount of solute that present in a unit volume of solution. Okay, is called a concentration. So concentration can be expressed in various ways, different ways that we discussed. And in that, so many are there, like volume percentage, mass by volume percentage, and molarity, mole fraction, formality, okay, normality, like this, so many are there, right? But here, in the previous class, in the synopsis 2, we discussed about the mass percentage, which is also called weight percentage, and volume percentage, mass by volume percentage, ppm. This we discussed, right? So in the synopsis 3, we are going to discuss about the molarity. What is the topic? Molarity. Okay. So very simple topic, very easy topic. Okay, but little concentration and practice is required, right? So molarity. What is meant by the molarity? So students, molarity is one of the method to express the concentration of the solution. Means what? How much amount of solute is present in the solution. Okay, that's called concentration. Okay, so here, how can you define the molarity? Molarity is very simple, the number of moles of solute. The number of moles of a solute present in 1 liter means what? 1000 ml also we can say of solution is called molarity, right? So molarity is what? The number of moles of solute present in 1 liter of solution. What is a mole? Already we discussed in the previous classes, the SI unit to measure the amount of substance in the chemistry is mole, right? So the number of moles of solute present in 1 liter of solution. So number of moles of solute. How can we write molarity? So it is denoted by capital M is equal to number of moles denoted by N by volume of solution in liter. So that is volume, okay, in liters. That's all. So the formula is very simple. So see students here, how simple formula? M is equal to N by V, where M is the molarity and N is the number of moles and V is the volume of the solution. Right? Now what are its units? What are its units? So units are what? So number of moles. Okay, so N is what? Number of moles. Okay, by volume. Volume is what? Liters. Okay, so now moles per liter. Moles per liter. Okay, so this is the unit of molarity. Is this clear to you? So molarity is expressed in the terms of moles per liter. Is this clear? So molarity is equal to number of moles of the solute by volume of the solution. Okay, now students here, here, I written that M is equal to N by V, where N is the molarity and N is the number of moles and V is the volume of the solution. Okay, is there any other formula for molarity? Yes. So there are so many formulas out there like molarity. Okay, I can see here N. N means what? Number of moles. And number of moles, how can you calculate? This also already we discussed. That is number of moles N is equal to weight of the solute by gram molecular weight of the solute. Okay, so here solute, so remember that. So N is equal to weight of the solute by gram molecular weight of the solute. Okay, so now if you substitute here, then what can we write here is m is equal to weight of solute by gram molecular weight of solute into 1 by volume of solution in liters. See students, terminology is important here. Weight of solute, this is solute and this is volume is in solution. Okay, so weight of solute by gram molecular weight of solute into 1 by V, that is volume of solution in liters. Okay, but you know that 1 liter is equal to 1000 ml. Yes or no? 1 liter is equal to 1000 ml. If I can write the same thing in another form, then m is equal to weight of solute by gram molecular weight of solute into 1000 by volume in ml. This is another formula. So students, here the formulas are very important. In the molarity, only there is a formulas. Okay, formulas are very important. Solution is nothing but here numericals are very important in this. Okay, so this one, so we can write m is equal to, so here 3 formulas are there, 3 are very important. So m is equal to n by v, m is equal to weight by gram molecular weight of solute into 1 by volume in liters, and molarity is equal to weight by gram molecular weight of solute into 1000 by volume. Like this we can write. And we can also write in terms of percent. If you can't write, then m is equal to percentage of solute into 10. Okay, percent of solute into 10 by volume of solution. This also the one of the formula. Okay, if we know the percentage of a solute, then we can use this formula also. Okay, next, for example, if we have one, for example, 2 solutions are there. Okay, like right. So now you have one solution. This is one solution. Okay. Now let the molarity of the solution is M1 now. Okay, condition 1. So the condition 1. Now here the molarity. Okay, molarity of the solution is M1. Let imagine M1 and volume is V1. Here volume is V1. Now for example, I am changing. Okay, so for example, imagine, okay, here I am adding some water here. Here I am adding some more water. Now what happens? Does the molarity remain same? No. As the volume changes, molarity also changes. So now in the second condition, after we are adding the water, then volume, I added the water, so the volume becomes V2. Volume becomes what? V2. And the molarity what happens? Decreases. So the molarity becomes M2. Okay. Now in this case, what we can say this, we have another formula that the product of these both under the first condition is equal to the product of these both. The meaning is what? M1V1 is equal to M2V2. This is also one of the important formula for molarity. Okay, means I have one, for example, I have 1 liter of solution is there. In that 1 liter of solution, that is salt solution. Let imagine that there is a salt solution. Okay, so in 1 liter of salt solution, imagine that I have added some example. Okay, I have added that like 2 moles of salt. Let imagine 2 moles of salt I have added, right? So now the molarity is number of moles by volume of the solution, right? Now what I am doing, for example, you think if I adding the water, means what? Volume is changing. If the volume is changing, then what happens? Molarity also changes. Yes or no? The molarity also changes, right? So in such cases, we can use this formula. Clear to you? So here you can have a page number 26. Then you can see that in molarity, if molarity and volume of the solutions are changed from M1 V1, so M1 V1 to M2 V2, then M1 V1 is equal to M2 V2. This is a very important solution, right? So this is also very important formula to solve the problems. Now we have one more problem, one more formula. For example, here I have one solution. Here also have another solution, right? So here there is a volume V1, okay, and the molarity is M1. For example, you see here, I am taking, okay, like this. This is volume V2, okay, and molarity is M2. Molarity is what? M2, right? Can you see here? So this is one solution, this is one solution, and the volume is V1 of this solution and molarity is M1. Here the volume is C little less, so this is another solution. This is V2, volume is V2 and molarity is M2. Okay, but remember here, these both are of solution of same solute. Solution of same solute. The meaning is what? Here, if it is a salt solution, this also should be the salt solution. If it is a sugar solution, this also should be the sugar solution. So these are the solutions of same type. Okay, same solute. Now, for example, if I mix these two solutions together, okay, if I mix these two solutions together, then what will be the resultant molarity? Okay, when we add these both, then what will be the resultant molarity? So, when I mix these both solutions together, the resultant molarity is equal to M1V1 plus second one M2V2, okay, divided by V1 plus V2. Now, total volume is what? V1 plus V2. So, this is one more formula, okay, to find the molarity of two solutions which are made up of same solute. Clear? So, these all are about the formulas of okay, molarity. So, once again, see here, molarity is the number of moles of solute in 1 liter of solution. That's the definition. And formula is molarity is equal to number of moles of solute by volume of solution liters. The units are moles per liter, right? Then, so number of moles by volume of the solution. So, but number of moles is equal to weight by gram molecular weight. So, on writing, so we can write like this also, molarity is equal to weight by gram molecular weight into 1 by V in solution. And M is equal to, like this, in terms of ml we are taking. So, like this. So, here, if one solution is there, if the solution molarity is M1 and volume is V1, if we change its molarity or if it changes its volume, then the formula is M1V1 is equal to M2V2. And if we have the two solutions of same solute of different molarities and different volumes, and if we add both the solutions together, then the molarity of the solution is defined by using this formula, right? So, this is about the molarity. Now, based on molarity, let's see one problem. I'll explain you. So, the problem, first problem in your material, page number 28, you can see calculate the molarity of the 6.3 grams of oxalic acid present in 500 ml of solution. So, see students here, I am explaining one problem here, problem number 1, okay. What is given here, calculate the molarity, So, the molarity we need to calculate. So, molarity M is equal to question mark, right. Of what we have to calculate of 0.3 grams of oxalic acid. So 0.3 grams means what? Mass. Okay, so we can write weight. Okay, so mass of solute. Okay, that's what I'm representing with W is equal to 6.3 grams, right? Then of oxalic acid present in 500 ml of solution. So volume is given. Volume V is equal to 500 ml. Is also given, okay, and solution molecular weight of oxalic is also given 126, okay, molecular weight means what? Gram molecular weight, okay, is equal to 126, right. So, now we have 1, 2, 3 values are there, fourth one we have to calculate. So, see here, we have need to calculate the molarity. We have the mass of the solute means weight of the solute, volume of the solution and gram molecular weight of the solute, right. So, which formula is suitable now? Is this formula suitable? No. This is condition when two solutions of same solute, but we have only one solution, right? So, this is also not possible. Yeah. So, now these two are suitable to us, but in these two also, here you see the volume is given in liters, here it is given in milliliters. In our problem, what they give? In milliliters, no? So, here better to use this formula, okay. So, molarity is equal to weight by gram molecular weight into 1000 by volume of solution in ml, right. So, here the gram molecular weight is given, that is 126, no. Now, which formula will be used? See, a molarity weight of the solute, volume, and gram molecular weight. So these four information where we have. So we have an information, this is not possible, this is also not possible. So here you see molarity, weight, gram molecular weight, and volume. Here also molarity, weight, gram molecular weight, and volume. But see students, here difference between these two is, here the volume is given in liters, here the volume is given in milliliters. So which can be used here? So what the volume is given to us? The volume is given 500 ml, right? So better to use this formula because its volume is given in ml. So it's easy to solve the problem. Clear? So now I will write the problems formula here. The formula suitable to solve this problem is G is equal to weight by gram molecular weight into 1000 by volume in ml, right? So this is the formula we need to use to solve this problem. Okay, chalo now let's solve now the problem. So now see, we substitute these values here. So m is equal to weight is 6.3, okay, 6.3 grams divided by gram molecular weight is 126. So write 126 into, here 1000 is there, so write 1000 as it is, no change, divided by volume in ml. Volume we have 500, right? So 500. Okay, now you know I think how to cancel. So here 2 zeros and 2 zeros get cancelled, right? Now 5 and 10, 5 ones are 5 twos are. This also will get cancelled. Now we can cancel 2 ones are 2, 6 are 12, 2 3s are 6, right? 63, right? Now 6.3 by 63. So 6.3 ones are 6.3 tens are. So now final what I got is m is equal to 1 by 10. So 1 by 10 is equal to what? 0.1 molar or moles per liter. That's all. Very simple. Okay. So here students, here two things you have to remember while solving the problem in the solutions. Not only in the solutions, any problem when you need to solve. Remember that first you need to prepare a data. Okay. What is given in the problem? Read the problem carefully and make the data what is given. So they are asking to see a problem, you see, calculate the molarity. Means you need to calculate the molarity. So write the molarity is equal to question mark. In 6.3 grams of 6.3 grams, so grams is there, so weight of the solid is given. Oxalic acid present in the 500 ml, so 500 ml represents the volume, so volume is equal to this one. And molecular weight is given, that's 126, so gram molecular weight 126 is given. So first you make the data and see the formulas. How many formulas are there? So 1, yes, this is first formula, okay, not first, here 2, okay, here 3, here 4, here 5, here 6 formulas are there. So in the 6 formulas, which formula is suitable to solve this problem? Okay. So based on that, that is most important to select the formula, which formula is suitable to us. Then if you know the formula, just write the formula, substitute, cancel, okay, you get the answer, right? So that's the problem. Now see students here, this is example problem actually what I have done. Now if you see the practice sheet, in the practice sheet, the second problem you see, second problem, the page number 29, the amount of sodium carbonate present. So see here, here second problem, in the practice sheet I am telling, practice sheet this is, okay, practice sheet, explaining the problem. So see here, the amount of sodium carbonate present in 10 ml of 0.1 sodium carbonate solution is, so see the problem what is given, the amount of sodium carbonate. So means what, you need to find the amount. Amount means what? Weight, mass of the solute, right? So now see how to solve this problem. So see a solution. So this is from the practice sheet students. This is from practice sheet. Okay, practice sheet. Practice sheet in that the second problem I am solving. Okay. So here the amount of sodium carbonate. Okay, so given means mass or weight. Okay, we need to find of sodium carbonate. Then what is given? Present in 100 ml. 100 ml comes under volume. Volume is equal to 100 ml, right? And then it is given 0.1 molarity. So molarity is also given, that is 0.1. Next, that's all students here, that's all is given. But here actually we need a gram molecular weight also. Gram molecular weight is not given here in this problem. Okay, of what? Sodium carbonate. Gram molecular weight of sodium carbonate is not given, but you know how to calculate the gram molecular weight of sodium carbonate. So see here, this is 106, you have to remember. Okay, If you can't remember, then you solve it. So how many sodiums are there? 2 sodiums are there. Each sodium atomic mass of the sodium is how much? I said that at least 20 elements atomic masses you need to remember, right? So 2 into 23, right? Plus how many carbons are there? Only one carbon. 1. What's atomic weight of the carbon? 12 plus 3 oxygens. Each oxygen atomic mass is how much? 16, right? So this. Now 2 into 23 becomes how much? 46 plus 1 into 12, 12 plus 3 into 40, 16, that is 48. So 48 plus 12 is 60, 60 plus 46 is equal to 106, right? So see here, 106. This is a method of calculating the gram molecular mass, right? Now, substitute the same formula, students. So, shall I stop here? Will you solve the same formula or shall I solve this problem? Will you try? Shall I solve? Okay, there's one problem I'll solve. Okay, so here you see molarity is equal to weight by gram molecular weight into 1000 by volume in ml, right? So molarity, so here molarity is given 0.1. So now what you do? So in the place of m, 0.1 is equal to weight, we don't know. So we need to calculate the weight. By gram molecular weight, we have 106, okay, 106 into 1000, okay, divided by volume. Volume is given 100 here, okay, so 100. So now you know that how to cancel, right? So cancel 2 zeros cancel. Now here 10 is there, if you would cancel, so this becomes 10.6, correct? Now this 10.6 you bring here, okay, so then it becomes 0.1 into 10.6 is equal to W. So 10 into 0.6, it becomes 1.06 grams is equal to W. Whether this answer is there or not in your options? Yes, third option is 1.06 grams. Clear, right? So that is the problem. Okay. Now similarly you can see the fourth sum also. The volume of water must be added to 100 ml of 0.5 molar NaOH solution to get 0.2, okay, molar of a solution is. So here this formula, this also based on molarity. So you can use this formula. This formula you can use. So but little modified form. Okay, little modified form. So the formula, the fourth one you see the problem. Okay. So here what we need to do is the volume of water must be added to 100 ml of 100 ml. So right here V1 is equal to 100 ml. Okay. And then to 0.5 molar sodium hydroxide. So M1 is equal to 0.5 molar, right? Now then what is given here? To get the solution of 0.2, so we need to make the solution as a 0.2. So that is M2, we need 0.2. Okay. Now the volume of water, how much should be added? So we need to find how much volume should be added. Okay. So the total volume is V2, right? So now here, what the volume should be added means what we need to do? V2 minus V1, because already 100 ml is there. Because already 100 ml is there. Now, if you find V2, from that, if you remove the 100 ml, then how much water should be added? Okay, we'll get that is V2 minus V1. Okay. Now, here what you do is equal to M1 minus M2 by V1 plus V2. This is the formula. Okay. So, this formula we need to use, M1 into V1. Okay, this formula we use here. So here let's see now how to solve here. So V2 minus V1, keep like same thing, V2 minus V1 is equal to M1, M1 is 0.5, so 0.5 minus M2, that is 0.2, okay, by M1, M1 is 0.5, okay, into V1, V1 is 100. Okay. So 0.5 minus 0.2 is 0.3 by 0.5 into 100. Okay. So 0.3 by 0.5. After point, both are one digit. So what we write? 3 by 5 into 100. Okay. 5 ones are 5 20s. Okay, so 3 into 20 is a 60. So V2 minus V1 is a 60 ml. Somewhere we are mistaken. I think once we check this problem once again, 60 ml is there? Is not there. The volume of water zero point 0.5 minus 0.2, correct only. So 0.5 minus 0.2. Oh, students, a little mistake we have done here. Okay, so that should be your 0.2 should be there here. I'm sorry. So 0.2. So V2 minus V1 is equal to, this becomes 0.3 divided by 0.2 into 100. Right. So now I think it will come. So 3 by 2 into 100. So 2 ones are 250 is a 53 is a 150 ml. Right. So here I have mistaken in small substituting here. So here M2 is a 0.2. So I have written the 0.5 there. Okay. So 0.5 minus 0.2 divided by 0.2 into 100. So then 0.5 minus 0.2 is 0.3 divided by 0.2 into 100. Okay. So now 0.3 after 0.1 digit, here also after 0.1 digit. So this becomes 3 by 2 into 100. So 2 ones are 250 is a 53 is a 150. So 150 ml. So the answer is 150 ml is a right answer, students. Okay. So this is about the molarity. Okay. This is what about the molarity. Right. Now, then we come to the next topic is molality. Molality also we discuss now. Molality. Okay. So what is molality? Okay. So molality is nothing but a, what is the definition you have seen for the molality? The number of moles of solute present in 1 liter of solution. 1 liter of solution, right? But here what we do, the number of moles of solute present in there 1 liter of solution. So just change that 1 liter of solution to 1 kg of solvent. 1 kg of solvent. Okay. So that's all. So here mass by mass, then mass by volume, here mass by number of moles by volume, here the number of moles by mass. Okay. So here see the definition is what? The number of moles of solute present in 1 kg. 1 kg means what? 1000 grams of solvent. So students, here formula remains the same like how you written the formula for molarity. The same formula will be there. Number of moles by, instead of volume, you will get K mass here. Okay. The weight by gram molecular weight into 1 by kg will come. Here kg. Okay, means mass. And here 1000 by kg. Everything remains same. Okay. So now see how can we write the formula for this one is molality denoted by small m is equal to the number of moles denoted by n, and here what is a 1 kg. Okay. So that is weight of a solvent. Weight of a solvent in kg. That's all. Okay. So that is the difference between the molarity and the molality. Is this clear to you? So the formulas will remain same. So the same formula we can also write. How we can write? Okay. In another ways, how can we write? Molality is equal to number of moles by weight in kgs. This is solvent. Remember that. So, but number of moles is equal to what? Weight of solute by gram molecular weight. So, if you substitute, what you will get here? M is equal to weight of solute by gram molecular weight of solute into 1 by weight of solution in kg. Okay. This is second formula. Then what is the third formula become here? The third formula become that M is equal to weight by gram molecular weight of solute into, instead of 1, what we write? 1000. Okay, 1000 grams of weight of solvent. This is weight of solvent in grams. Okay, so this is the other formula. So that's the main difference. There we are taking in terms of volume, we are taking the molarity. In the molality, we are taking the weight of the solvent, right? So here, based on this, if any problems are there, okay, once you see the practice-based questions, practice sheet, page number 29, the unit of molarity, already I said you that moles per liter. See here, moles per liter. So this is the answer. So the option is second option. The amount of sodium carbonate, just now I solved you this problem. That is 106 we got. So this one. Okay. So this is 1.06, the third option. And the number of moles of the solute present in 600 ml. Okay, this you solve the, okay, some problems you need to solve here. So this is a third sum. fourth also I solved. And fifth, if the molarity of the solution is M, molarity of the solution is M, then decrease the molarity of the solution to M by 2 then. So if the molarity decreased, they said, to half, then what about the volume? Volume will be doubled. See, if you are having, take 1 glass of water, in that 1 glass of water, some, okay, half glass of water, in that some salt is added. Now you taste the water, okay, it will be salty. Now what I am doing, I am adding more half glass of water, okay, then does the water taste remain same? No. Yes or no? Water is more. Now the salt taste will be decreases. The means what? Molarity is decreased. So here the question is what? If the molarity of the solution M is decreased to half, then the meaning is what? Volume is doubled. So the option is third option. And fourth option is also a problem, simple problem, that is, okay, do it. And seventh, eighth, just formula, molarity is equal to number of moles of solute by volume of solution in liters. Yeah, nothing option is correct there. All is given in solute only. So that question is wrong. And the relation between the molarity and percentage, just now I give that percent of solute by molecular weight of solute into 10. The second option. Molarity is inversely proportional to temperature. See, this is also very important. As the temperature increases, molarity will be decreases. Why? As the temperature increases, volume increases, students. As the temperature increases, volume increases. Yes or no? Okay. So based on this. Okay. So here you try to solve the questions. All the formulas are on the board. And so with this we stop this chapter, this topic. Okay. And try to solve the remaining sums. Right? Okay then. Bye. Take care.